What is a locus? A locus is a set of points in geometry that satisfies one or more specified conditions. Essentially, it represents the path taken by these points as they move according to specific rules or limitations defined by mathematical relationships. The term locus comes from the Latin word for place or location. In mathematics, a locus truly shines as a tool to visualize and understand geometric concepts. It's essentially the collection of all points that fulfill a specific rule or set of rules. These rules can be quite diverse, adding a rich layer of problem solving to geometry. Here are some common ways conditions for a locus are expressed. Distance relationships. Imagine a point fixed in place. The locus of all points always the same distance away from this fixed point forms a circle. This makes perfect sense if you picture drawing a compass around the fixed point. All the points on the circle are the same distance from the center. Angle relationships. Now consider two lines intersecting at an angle. The locus of all points exactly the same distance from both lines falls on the perpendicular bisector of that angle. In essence, every point on the perpendicular bisector is truly equidistant to the two original lines. Algebraic equations. Every graph you encounter in mathematics is, in a way, a locus. It represents the collection of all points whose coordinates satisfy the equation that defines the graph. For example, the familiar equation x squared plus y squared equals 1 graphs as a circle, which makes sense because every point on the circle fulfills this equation. By visualizing the locus, you gain a powerful tool to reason about geometric relationships and solve problems. Imagine a point constrained to move according to a certain rule. By pinpointing the locus of this point, you can predict its possible locations and solve for its position based on the given conditions. Finding the locus becomes a strategic approach to tackling geometric challenges. Historical perspective. Before the 20th century, geometric shapes were not considered as infinite sets of points. Instead, they were viewed as places where a point could be located or move. For instance, a circle was defined as the locus of points equidistant from a fixed center. However, modern mathematics describes shapes as sets of points that satisfy specific conditions. This shift in perspective allows us to define shapes more rigorously. Examples of Loci in plane geometry. Here are some examples of Loci in plane geometry. 1. Perpendicular bisector. The set of points equidistant from two given points forms the perpendicular bisector of the line segment connecting those points. For example, consider 2 points A and B. The perpendicular bisector of AB consists of all points equidistant from A and B. 2. Angle bisectors. The set of points equidistant from two intersecting lines is the union of their two angle bisectors. Imagine two intersecting lines, and the locus of points equidistant from them. 3. Conic sections. All conic sections, circle, ellipse, parabola, hyperbola, are defined by Loci. For instance, a circle is the locus of points equidistant from a fixed center. Practical applications. Loci have practical applications in various fields. Critical locus, the set of critical points of a differentiable function. Zero locus, vanishing locus, the set of points where a function takes the value 0. Singular locus, the set of singular points of an algebraic variety. Connectedness locus, the subset of parameter space where the Julia set of a rational function is connected. Conclusion. In summary, Loci provide a powerful way to describe geometric shapes and their properties. Whether you're studying curves, surfaces, or other shapes, understanding Loci enriches your mathematical toolkit.